Now we are going to take a look on this application of GDT. In this application, there are 4 different types of categories or equally splitted here. This is what we need to consider while designing or giving a GDT. We can eliminate and learn how to reduce the errors in manufacturing and inspection by using of a GDT. With the GDT, we can control the variations between the components. Also, it helps to assemble individual parts, reduce the scrap, and universal languages. These are the 4 different terms with the 4 different kind of explanations. First of all, what is a control variations? Control variations means it is nothing but if you mating a bolt and nut together, you need some kind of a variation difference, because either you have a positive difference or a negative difference to mating with each other. Suppose if you have a similar number of limits, means you cannot able to mate within each other. Look at this component. In this component, I directly enter into the drafting page. In this page, I am applying the exact dimensions of this outer values. Just to take it as a reference by using the SolidWorks, I am only giving the outer dimensions in this portions. Choose whatever the area, I am giving the outer portion. That is what the tolerance limit and the ranges we are going to control in this exact area. Now look at this 3 different views with the 3 different dimensions. It has a precision of 0.00. Suppose if you machining the component, likewise using a milling machine means you have some kind of a cutter to remove this exact process. Using this process, you cannot able to make a 100% perfect part. That's why we need a variations, but that variation must be controlled using a specific type of a limit. This is called a tolerance limit. Look, first I am going to select this part and applying a tolerance with the plus or minus values, either bilateral tolerance or symmetrical tolerance. I am applying a symmetrical tolerance with the limit range of 0.5. Once you apply the tolerance, it must be within this ranges itself, that is 166.5 or 165.5. This is the ranges we need to control. In this range only the outer part must be designed. Afterwards, it can able to made with another type of the part. In this case, we can't get a 100% perfect product, but we can get a controlled product. Likewise, what is the exact machining process? What is the control ranges we need to set in these conditions to made with another component? All that limit we can set by the each other. Okay, this is how the variations are used in this exact parts. In both vertically, horizontally, any kind of dimensions you want, select the particular portions and apply the tolerance limit. Later we see in detail how to apply the tolerance and where we can exactly use it. Okay, all that thing we can see in detail at later sections. Just to see how the dimensions is applied, what is the exact purpose of using a GDT. This is the first factor we need to consider, that is called control variations. These are the different types of tolerance limit. Suppose if you select a limit tolerance, you can only get a values within the limit ranges. That's why it is exhibits like that. It is not shows the tolerance zone, it only shows the limit zone. Also, we can detailedly know by using office datums. Datum is nothing but there are 2 different kind of datums. One is a permanent datum, another one is a temporary datum. What is the exact use of it? It is just to fix the parts to the particular portions. If I select the primary portion A, means it first fix on that portions itself. That is the primary portions. Likewise, if you position the part, the example, assemble a piston within this connecting rod, it is a permanent connections. But assemble the shaft to the chuck, it is a temporary connections. These are the difference of datums, permanent and temporary, just fixing your component to the exact portions. That is called datum. Applying a datum with the different terms means different kind of a name with right explanations. Now the next one is assemble parts. Assemble parts is nothing but with the right tolerance only we can able to make the parts exactly to the particular portions. Suppose if you look at the engine parts, in this engine part there are a lot of components are assembled together. Either you want to fix with a tight tolerance or you can fix with the loose tolerance. It controls the, if you have a more kind of vibrations means you need to fix with, you need more precision parts. That's why a GDT plays a major role in this category to assemble within each other. Next one is reduces scrap. GDT is not only for an assembly, it is also easy to reduce the scrap, because if you apply GDT means you can have a right type of a machining process or right type of an inspecting processes to measure the components or machining the components, easy to reduce the scrap also. Because 14 different symbols explains a 14 different type of a machining process, it is also helps to reduce the scraps in these conditions. This is how it can reduce the scraps in these portions. If you machining any type of a cylindrical components or any complex shapes using different type of machines with a different cutter dimensions, means you have some kind of a tolerance to control this one. Okay, now the next one is last part, universal language. Because we don't use any type of a language called a general term, English language or a Hindi, Tamil, any other languages we not using in this communications. We only using a symbols to communicate to other persons, because different GDT have a different kind of a symbols as well as a tolerance limit, either numerical value or a symbols you use to communicate to one person to another person from different country, different resources, all that have the same kind of a limit, like ASME Y 14.5 standards. Okay, this standards is only used for all over the world to communicate within each other. This is what we get after completion of a GDT applying to the exact drawing, and this drawing is easy to understandable to the manufacturers who can machining, also easy to understandable for inspection persons who can inspect by using of this exact product. Now look at this example. One part are mating with another component with an high precisions. This is how the GDT helps to get a more accurate, but high precision demands high cost.